Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
So friends, there is another question which is of different type, which is based on that is molar volume. So let us see the question, what are they asking about. So the thing that they are saying that we have to calculate the volume of oxygen required for complete combustion of 0.25 mole of methane at STP. So the first thing is we should know that what will be the combustion reaction when methane is being reacted with oxygen. So the first thing that I'm going to do is I'm going to write the reaction of it, and then only we could decide that what would be the answer that we need. So the thing is, methane is being reacted with oxygen. So therefore, 1 mole of methane, suppose, is been reacting with oxygen. And we should know that when methane reacts with oxygen, it forms carbon dioxide and water. And this kind of numerical or this kind of reaction we have did earlier also. So the carbon dioxide and H2, this is what we would get. But if you observe that the total atoms of carbon on the left hand side, that is when I'm talking about the reactant side, is 1, while that of in product side is also 1. While talking about the hydrogen on the reactant side is 4, while that of on the product side is 2. While that of the oxygen is 2 on the reactant side, while that of in product side it is 3. So the thing that we have to do is we have to balance it. So how could we could balance it? So suppose if I multiply this oxygen by 2, that is I am changing the stoichiometry as 2. So eventually I have to change this stoichiometry of this also. So now everything has been balanced. That is, the carbon was already balanced, and now the hydrogen is also been balanced. And talking about the oxygen, again it is being balanced. So this is the thing that we have did by converting it into a reaction format. So now the next thing that we are going to do is we are going to write the data that they have provided to us. So what they have asking is, as you could see, that is 1 mole of methane requires 2 moles of oxygen. So therefore, if I'm talking about 1 mole of methane, that means how much volume, if I could convert in the volume also. So suppose 1 mole, that is 1 mole of CH4, that is methane, will occupy 22.4 dm cube of volume. So when we are talking about 0.25 mole, then what would be the volume of the methane that we are going to take? So suppose then 0.25 mole of CH4 will occupy X volume. Suppose this we don't know, then how to calculate? So it would be very much easy. What I'm going to do is I'm going to cross multiply. If I'll cross multiply this thing, so let us see what is the answer that we could get. So therefore I could write it as X is equals to, that is 22.4 multiply by, that is 0.25 moles divided by 1. So if I calculate this thing, my answer would be 5.6. Again we are talking about volume, so therefore this would be 5.6 dm cube of methane, of the oxygen that we need. But we are not talking about oxygen. We are talking about that we are talking about in a relationship, that is 1 mole of methane will occupy 22.4 dm cube of methane. So therefore 0.25 mole of methane will be, that is 5.6 dm cube of methane. So this is the value of X that we have got. But if we see the reaction, we could easily estimate that if 1 mole of methane needs 2 mole of oxygen, so I could say in a very clearly that suppose if 0.25 mole of methane will occupy the double moles of oxygen, that is 0.5 moles of oxygen. So therefore, if the volume of the methane is being given, or we have calculated it as 5.6 dm cube of methane, so the volume of oxygen that is required will be the double of that is 5.6. so therefore the volume of oxygen required will be 2 times that of the methane, that is 2 into 5.6. So this will give you 11 point, I'll calculate it, yes, 11.2 dm cube of oxygen. So this is what we have calculated. Means for in this reaction, 0.25 moles of methane will require 11.2 dm cube of oxygen, so as to give a combustion, that is for a complete combustion reaction, so as to obtain carbon dioxide and H2O molecule. So thank you friends for watching this video. I hope you have understood this kind of numerical and you have got an idea that how you could solve this thing by the given data or the given question that is provided to you. So share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.